before we end with this chapter, Maddie? Proof by induction. Ooh, that's exciting. That sounds like an exciting thing to learn, right? Before group, right? Proof. Alright, so this sounds kind of complicated, but it's really not. If you have two events, and the first event can happen in so many ways, I call it M1, and the second event can happen in M2 ways, the number of ways that the two events can occur, this is like a SAT problem well, used to be when I took the SAT. If you have 3 pair of pants and 7 shirts, how many different outfits can you make? What do you do to figure that out? You could do a whole big tree and figure it out, but you just multiply the number of ways that it can happen. So if the first event can happen so many ways, you have 3 pair of pants, and the second event you have 7 shirts, the number of different combinations is you just multiply them together. So it's just M1 times M2. So we can take that basic idea and then expand it and do a whole lot of problems with this. So we're not going to do it simple. Maybe there's one question on homework today that's simple, like if you have this many 3 main dishes and 4 vegetables, 3 whatever, how many different combinations can you get in use? Like on Pizza Hut commercials or Subway commercials, and they're like, there's this many ways that you can order pizza from us or a sandwich from us. They just take all the different things and multiply them together. We're going to do more stuff like number 1 here. How many different license plates are possible if each license plate has 3 letters followed by 2 digits? And here's my go-to way that I do this. I make a little list of how many things I'm filling in. Right? I'm having 3 letters, so I'm going to put 3 spaces. Not 3 in this case. Followed by 2 digits. And the fundamental counting principle says if I can figure out how many options go in each spot, I'm just going to multiply those together, and that's going to give me the total number of license plates. So, 3 letters. How many letters are there in the alphabet? 26. Does it say anything about them not being able to repeat themselves? Can they repeat themselves? It doesn't say they can't, right? So can I say 26 times 26 times 26? If it said they can't repeat themselves, then you would have to go 26, 25, 24, because you're losing 1 each time. Followed by 2 digits. How many digits are there? Single digits, right? Are there 9 single digits? Because there's 0, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 digits. That's why we're base 10 number system, because there's 10 digits. And again, it doesn't say they can't repeat themselves, so we would just say 10 times 10. And then you just multiply it. This is definitely a calculator-heavy test. And then after break, catch. Like that. Yeah. Oh my gosh. Yeah. One. Right, 1,757,600. Questions about that? All right. Then we have these things called permutations and combinations. Remember that? Yeah. Permutations are when you arrange items in orders. Like how many ways could you have first, second, and third place in a race? Order matters, because if I get first and you get second, that's a different combination than if you get first and I get second. So it's when order matters. So I think you should write order. So my example here are how many ways can 5 people line up. We're talking about how many ways can they get in order, first, second, third, fourth, fifth, then order matters there. And so we could do just like the license plates and put our little lines, and this is first, second, third, fourth, fifth. many people could I choose to be line leader? For the days of line leader taking very big deal. How many people could be line leader? 5. Once I pick line leader, how many can be second in line? Backup line leader. There's only 4 left now, right? Like the old game of picking. Did you guys ever do that in PE where you just pick people to be on your team and then you just stand there waiting to be the last person to pick? And then there's only 3. And then there's only 2 people. And then the last person standing there, there's no choice. They have to be last. There's only 1 spot there. And again, the fundamental counting principle says I can do 5 times 4 times 3 times 2 times 1, which is the same as, you know what that's the same as? Right? Have you ever seen that before? You could like be like 5 because it's really excited. It's really exciting. No one watches my videos. Let's see. But you can hit 5 times 4 times 3 times 2 times 1, or on my calculators, and if you have a different calculator, you'll have to find it. But on my calculator, right next to log in the second column is a probability button. And if you arrow over, if you hit 5 and then hit the probability button, you have to go over to the third one, but it's on the screen. It's just an exclamation mark, and you can hit factorial. And 5's not a hard one to do, but it'll give you the answer, which is 120. If you're going to do 20 factorial, right? That's a really nice button because you don't have to hit 20 times 19 times 18 times 17. Factorial means every number times every integer down to 1. So we can say there are n factorial ways that n elements can be ordered. And if you don't think of it as n factorial, right? Sometimes I don't know where those buttons are on it. Alright, let's look at that. And again, the hard part is going to be when you're doing your homework, when you're doing a test, is you have to think about, does order matter and does order not matter, because it changes how you do things. But then this one says, if you have 6 books with room for only 3 on a shelf, how many ways are possible? So now I have 6 books, but I'm only going to take 3 of those. So we could do this just like we did the other one. I only have room for 3, so that means I only get 3 spots, right? But it's not 6 factorial now, it's not 3 factorial now, because I have 6 total books to choose from, which means for the first spot, I can choose 6 books, then I can only choose 5, and then I can only choose 4. That is not factorial because it didn't go all the way down to 1. You follow me on that? That happened to turn out to be 120 again? What's up? So this is a permutation when you have so many items but you're only choosing a few of them. You can do a permutation, and you might have already saw that button on the probability button when we did it. You can say the number of permutations of n elements taken r at a time. You can say NPR, and the formula for that, I'm going to show you the formula, and then we'll talk about the button on your calculator. But the formula is you take n factorial. So if you're choosing all of them, like in the lining up, you have 5 people and you're choosing all 5, it's just 5 factorial. But if you have 6 books and you're only choosing 3, then you have to take over n minus r factorial. So it's how many you're taking divided by n minus r factorial. I just want to show you, using that formula up here, what that would look like. So if I had 6 books, but I'm only picking 3 of them, we say 63, and then we would say that's 6 factorial over 6 minus 3 factorial. And you can type it on your calculator, but I just want to show you 6 times 5, that's 4, that's 3, that's 2, that's 1. 6 minus 3 is 3 factorial. So you can kind of see where that comes from, of the 3, 2, and the 1 are going to cross out. And you're just left with what we did, 6 times 5 times 4. I also want you to know how to use that button on your calculator. So again, if you have a different calculator, the hard part is finding that button. But on my calculator, if you hit that probability button, it's the very first thing that comes up. It says NPR. That says NPR. But you have to put the N in first. So like if you were typing in the calculator, you would hit 6. Then you would go to probability and hit this button. Then you would hit 3. And you just hit enter and it should give you questions about that? Anybody? Okay, so look at the next one. I want you to do it both ways. I want you to use the formula, and then I want you to type it in your calculator and check that you get the same answer. So the formula, remember, is n factorial over n minus r. Do the formula, and then type it in your calculator. And maybe even do the formula without hitting the factorial button. Like right now, see that all without that has to do. As I was reading this homework over break, some people that had missing assignments, and so I wrote on there what you were missing. You have the assignment sheet, I wrote on there what was missing. I wrote that there, so pass that somewhere. I just didn't see it. Not very much good enough. Sometimes everything. And then the button's really easy, obviously, right? There are 2 questions on your homework, I think, that I make you, like I'm going to tell you in here, like use the formula. I want you to use the formula. There's going to be a couple on your test that I say, show me the formula, and then you can check with your calculator as well. So, all right, what else do we have with permutations? What if you're talking about, like, the best example for distinguishable permutations is we want to talk about how many ways can we rearrange the letters in a word. Because if the letter repeats itself, if we replace an N with an N, that's not distinguishable. You can't tell that you moved an N. And so it says, suppose a set of N objects has N1 of one kind of an object, N2 of another kind, and so on, N1, N2, all the way up to Nk. The number of distinguishable permutations, you cannot use the button on your calculator for this. Alright, so you have to take the number of objects, which is n factorial, or if we're talking about letters here, that's going to be the number of letters in the word. So how do we ever use this? But then you have to divide out each letter the number of times it repeats itself. Alright, so you could actually do every letter the number of times it repeats itself. But what's 1 factorial? 1. So for me, I only include the ones that repeat themselves more than once. So for me, on the bottom here, I take each letter that repeats itself, or how many times it repeats itself. We'll do that. Mississippi is a good one to do because there's a lot of repeating spaces. But we'll be boring and we'll do it. So I'm not saying we're actually making words out of this, right? So how many different ways can we write the letters in Indiana? They're not words, but how many different combinations could we combine the letters? So we're going to take the number of letters in Indiana. 1, 2, 3, 4, 5, 6, 7. We're going to take 7 factorial. And then each letter that repeats itself, the number of times it repeats, we're going to do that factorial on the bottom. So, there are 2 i's, so I do 2 factorial. There are 2 n's, so that's another 2 factorial. And there are 2 a's, which is another 2 factorial. If you want, D only appears once, and you could do 1 factorial for D. But it's 1, so I don't ever put that one down there. Does that make sense? If you want to, a nice way to check that you got everything is if you put the 1 down there, you can check that 2, 4, 6, 7 letters you accounted for at the bottom. If it repeated itself 4 times, you would do 4 factorial on the bottom. If nothing repeated itself, then you don't have to divide by anything, because every permutation would be distinguishable. If you're typing this all in your calculator, be really careful, right? If you just type 7 factorial divided by this, your calculator is going to do order of operation, and it's going to divide by 2, and then it's going to multiply. So I'm a really big fan of, if you're typing things in your calculator, do the bottom separately, and then take the top divided by the bottom, or you've got to do parentheses on the bottom, right? You've got to make sure you're typing things in correctly on your calculator. For me, I like to cross things out. I should like the dark ages and the dark ages. Like this. Cross this out, and then 2 times 2 is 4. So that crosses out, and then I go to my calculator. I don't know why. 630? Did you get 630? So there's 630 ways, distinguishable ways, that you could rearrange letters. What happens on the test every year is when I ask you how many ways can you rearrange letters, people use the permutation button and they get the wrong answer because they're using the wrong formula. You just have to make sure you know not the permutation button on. Okay. Questions about that? We're flying. All right, one more thing. What if order is not important? Like, what if I just wanted to say, of 7 choices for dinner, how many ways could I make a meal? That's 5. Order doesn't matter. I don't care which one I have on this day. Or this is a good example of 12 pizza toppings. How many ways could you just choose 2 of those? It doesn't matter if you call and ask for pepperoni and sausage or sausage and pepperoni, you get the same pizza, no matter which way you order it. And so the big thing that you have to be able to distinguish on your homework and on your test is, does order matter? So when you read these questions, you have to think about, does order matter? So combinations are when order does not matter. And so you probably saw on your calculator, it's probably right next to the permutation button, is the combination button. And you're going to take n factorial divided by r factorial, and then n minus r factorial. And again, that's how your calculator does those. You just type that button in. So number 6, let's actually use the formula, and then we can check on the calculator. And then number 7, we can. So if I have 10 items and I'm just choosing 6, and I don't care what order, right? So I would take 10 factorial over 6 factorial. And then 10 minus 6, I'm just going to go ahead and say that's 4. And again, if you're typing it in all at once on your calculator, just put parentheses on the bottom. I like to cross things out. I like combinations. They're usually a lot smaller numbers because you're dividing by more stuff. So I know that the 6 factorial, right, I did 10 times 9 times 8 times 7, and then I know all the rest of that's going to get off the 6. And then I'm going to say 4 times 2 is 8, it's going to take off 8, and 3 is going to go into 9 3 times, 7 times 3 is 21 times 10. I get 2 10. I get 2 10. Did you type it in all at once? If you're doing it all at once on your calculator, you got to hit 10 factorial divided by parentheses 6 factorial times 4 factorial. Because again, your calculator is going to do order of operations. Tell it to be at the bottom. Or just do the top, do the bottom, and then divide it. That always works too. So that works. So you try to get to it. And again, there's a couple on your homework that I'm going to tell you, do the formula. I want you to practice the formula. And then the rest of them, if it's a permutation or combination, I also want you to be able to use the calculator. And on the test, it'll be a whole calculator test. You're going to check the ones that I want you to show the formula on. If you're practicing, I want you to know the formula. And so then on this one, right, how many ways can I order 2 toppings from 12? Order does not matter. So the bigger number is the first number. So of 12 toppings, I'm choosing 2. And then you can just type that in your calculator to do that. But the big thing on that is it a permutation? Is it a combination? And that's the formula. And hopefully it's 66. It's kind of a big hodgepodge of problems today. Some of them are about license plates, and you just make the whole thing, plug in the number to multiply them. Some of them are combinations, some of them are permutations, and I'll talk about the questions tomorrow that you have over it. And then tomorrow we're gonna look at something kind of a little different that uses combinations, but it's called the binomial theorem. And then we're going to do probability. So the hard thing I think with this exam is I feel like it's really disconnected, whereas a lot of our chapters build up to being able to solve those complicated problems. Whereas this chapter, I just feel like it's a bunch of different topics joined together. So 3 through 18 multiples of 3, 19 through 23 all. I think those are like permutation or combination. And then 24 through 45 multiples of 3, and 46 through 48. I know it seems like a lot, but they're not that long to do. There's a lot of calculator stuff, so you definitely want to have a calculator to use if you need to borrow one from me during the day for study hall. People come in and out and borrow them all the time and bring them back. But know that you have a calculator on your smartphone if you have a smartphone, or if you have a computer or any kind of electronic device, that there are calculators on that. So if you don't know how to get to a calculator, let me know. Desmos.com is an online graphing calculator. But it does all the computations as well. So there's also free calculator apps if you have a smartphone that you can get really fancier calculators than the one that just comes on most smartphones. 15 and 18, I want you to use a formula for combinations and permutations, but the rest of it you can use the button on the calculator. So if you have questions about using your calculator, or if you have test correction questions, great time to do that now. Otherwise, you need to work on this, or you need to work on your test corrections. Okay, and I'm going to work on grading that stuff. And definitely, if you're not sure, check your answers in the back, like your odd answers. Also, I have all this stuff worked out, so if you ever have a question, you can want to check the answer with me. Like, I have all the homework for that time too. Okay. And then I'll work on getting you the final sheet. So, when you buy, we don't need practice. Okay? So, when you buy, the internet. So, once buy, that shortcut is, if you see minus, that is all that's going to be. So if you don't want to do that, you can just take minus. on this one,